All right, the learning target for today is to be able to create and use graphs for qualitative data. You're a 3 if you can create and use graphs for qualitative data. 2, you can create and use some graphs for qualitative data. 1, you can create or use some graphs for qualitative data. Or 0, you cannot create or use graphs for qualitative data. Oh, hey, by the way, how are you today? That's great! Section 2.2, bar graphs, circle graphs, and time series graphs. Focus points for today: determine types of graphs appropriate for specific data, construct bar graphs, Pareto charts, circle graphs, and time series graphs, and interpret information displayed in graphs. So back at the learning target and scale, when I said to be able to create and use, when I'm saying uh, use means to be able to read it, but also determine which graph is most appropriate for that data. So histograms provide a useful visual display for of the distribution of data. However, the data must be quantitative. In this section, we examine other types of graphs, some of which are suitable for the qualitative or category data as well. Let's start with bar graphs. These are graphs that can be used to display quantitative or qualitative data. So you may have thought of histograms and bar graphs being the same, but histograms are specifically for quantitative data. They're over a range. Bar graphs can be used for quantitative data, but are often used for qualitative data. So features of a bar graph. They can be vertical or horizontal, whichever you think best shows your data. The bars are of uniform width and uniformly spaced. So same amount of space apart, same amount of space in the bars. The only thing that differs is the height. The lengths of the bars represent values of the variable being displayed, the frequency of occurrence, the percentage of occurrence. The same measurement scale is used for the length of each bar. The graph is well annotated with title, labels for each bar, and vertical scale or actual value for the length of each bar. So make sure you correctly annotate and label all parts of your graph. So here I have 2 bar graphs that depict the life expectancies for men and women born in the designated year. If you notice, these are actually the same exact graphs. The only difference is on the left, we have the range for your age going from 0 to 100 evenly spaced out. On the right here, though, we essentially start at 65. And we have this little notation, which I'll talk about more in a second, breaking off. So this says there's a break, a discontinuity between 0 and 65. It's not evenly spaced, and you need to show that. So then it goes by fives all the way up evenly. So it makes the data look different. The left one makes the men's ages look pretty close to the women, but on the right, there's a big difference. Even though it's the same data, it's what you look at it. The graphs we just saw are called clustered bar graphs because there are 2 bars for each year of birth. One bar represents the life expectancy for men, and the other represents the life expectancy for women. The height of each bar represents the life expectancy in years. So it's comparing the two. And clustered bar graphs are very good at comparing different things. usually within different years. So you can see all the years, but also comparing different groups in those years. An important feature of illustrated in the second graph is that of a changing scale. Notice that the scale between 0 and 65 is compressed. The changing scale amplifies the apparent difference between lifespans for men and women, as well as the increase in lifespans from those born in 1980 to the projected span of those born in 2010. Whenever you use a change in scale in a graphic, warn the viewer by using a squiggle. Yes, that is the official term, on the changed axis. Sometimes in a single bar, if a single bar is unusually long, the bar length is compressed with a squiggle in the bar itself. So if not all the bars need a squiggle, just one, you would put the squiggle inside the bar. A Pareto chart is a bar graph in which the bar height represents frequency of an event. In addition, the bars are arranged from left to right according to decreasing height. And there's a nice example of that in your book. Another popular pictorial representation of data is the circle graph, also known as the pie chart. It is relatively safe from misinterpretation and is especially useful for showing the division of a total quantity into its component parts. The total quantity, or 100%, is represented by the entire circle. Each wedge of the circle represents a component part of the total. These proportional segments are usually labeled with corresponding percentages of the total. In a circle graph, wedges of a circle visually display proportional parts of the total population that share a common characteristic. So this shows less about value and more about proportion. How much of something is shown rather than how much is shown. So it's dealing just with proportions of the whole rather than how much. Another kind is a time series graph. It's a graph to show data measurements in chronological order. To make a time series graph, we put time on the horizontal scale and the variable being measured on the vertical scale. In a basic time series graph, we connect the data points by line segments. In a time series graph, data are plotted in order of occurrence at regular intervals over a period of time. Suppose you've been walking or jogging, or been in a walking, jogging exercise program for 20 weeks, and for each week you have recorded the distance you covered in 30 minutes. Your data log shown below. So, make a time series graph out of that. So, the data is appropriate for a time series graph because they represent the same measurement, the distance covered in 30 minutes, taken at different times. The measurements are also recorded at equal time intervals every week. To make our time series graph, we list the weeks in order on the horizontal scale. Above each week, plot the distance covered that week on the vertical scale. Then connect the dots. Be sure that the scales are labeled. Remember, you always want to label everything. And again, notice the squiggle. So we didn't need anything from 0 to 1, so we didn't have to make it as long as the rest. From looking at the figure, can you detect any patterns? There seems to be an upward trend in distance covered. The distances covered in the last few weeks are about a mile farther than those over the first few weeks. However, we cannot conclude that this trend will continue. Perhaps you have reached your goal for this training and now wish to maintain a distance for of about 2.5 miles in 30 minutes. So going back to the graph, so sometimes you go up, but sometimes you go down. However, you still see the trend of improvement. So you are improving over time, and that's what the time series graph is good at showing. It's good at showing that you're improving over that span. However, like they said, after this, you could go off. Like you could decide, I'm fine with 2.5 and stay there. Or you could keep trying to improve and you can't get any better after that. This just shows over the 20-week period. Data sets composed of similar measurements taken at regular intervals over time are called time series. Time series are often used in economics, finance, sociology, medicine, and any other situation in which we want to study or monitor a similar measure over a period of time. A time series graph can reveal some of the main features of a time series. Time series data consist of measurements of the same variable for the same subject taken at regular intervals over a period of time. All right, quick review on how to decide which graph to use. Bar graphs are useful for quantitative or qualitative data, but with qualitative data, the frequency or percentage of occurring can be displayed. With quantitative data, the measurement itself can be displayed as well as was done in the bar graph showing life expectancy. Watch that the measurement scale is consistent or that a jump scale squiggle is used. Pareto charts identify frequency of events or categories in decreasing order of frequency of occurrence. Circle graphs display how a total dispersed into several categories. The circle graph is very appropriate for qualitative data or any data for which percentage of occurrence makes sense. Circle graphs are most effective when the number of categories or wedges is 10 or fewer. Time series graphs display how data change over time. It is best if the units of time are consistent in a given graph. For instance, measurements taken every day should not be mixed on the same graph with data taken every week. So bar graphs, anytime you want to compare multiple things over a span, it's good for a cluster bar graph, but also if you want to look at more amounts, you're looking at bar graphs. So if you want to compare the ages of things or just amount of something happening, amount of book sales or in a type of genre or something to that effect, you would use a bar graph. Pareto charts, specifically if you want to look at the frequency in decreasing order. So that's specifically starting with the highest and then going to the lowest, showing a decrease there. Bar graphs are usually organized depending on how it is, usually could be randomly, could be alphabetically, could be chronologically if you're dealing with years. Circle graphs, if you want to show percentages, comparing how much of something is used compared to something else. Time series graphs change over time. If you want to look at the same thing and how it changes over time, you want to use a time series graph. And just as a note, for any graph, provide a title, label the axes, and identify units of measure. As Edward Tufte suggests in his book, The Visual Display of Quantitative Information, don't let artwork or skewed perspective cloud the clarity of the information displayed. So just because you want your information to look good, don't have that take away from the data that's there. All right, now time for the sponge activity. So, uh, pretty simple one this time. What kind of graph should be used for each situation, and please explain. So, first, the percent of people that use each internet browser. Next one, the percent of people with ALS in the US each year. And how many male, female, and genderless characters are in each Pixar movie. So that's it for the lesson. Once again, please make sure to take notes in the entire lesson. Attempt the sponge, take a picture or video of all your notes. Please make sure I can read them. Please remember to go back to the scale and rate yourself where you are. Submit it all to Google Classroom, and have a good night.